Good morning, everyone. Welcome once again. As part of our ongoing lecture series with leading researchers in the field, we continue exploring methods for conducting empirical studies in software engineering. Today, we are very pleased to welcome Professor Sira Vegas from the Technical University of Madrid. She has extensive experience in empirical software engineering, particularly in experimental studies. Sira, it is a great pleasure to have you with us. Thank you very much for accepting our invitation and for sharing your experience with us. I'll now hand it over to you. Please feel free to start your presentation.
Okay, thank you very much. The first thing, I just realized that the date is incorrect. So in my first slide, it appears March 25th. So I hope that that's the only mistake that there is in my presentation. My presentation has to do with or explains the design that we follow when running one of our experiments. I will go through the description of how was this design and planning and so forth done, trying to justify the rationale for each of the decisions that we made. So any questions you may have at any moment, please do not hesitate to ask anything. Since I cannot see anybody because I can only see the screen with my presentation, please feel free to speak, because the only way I am able to know whether you want to say something is by you speaking. I cannot see anybody. So yeah, I will start with my presentation. So the experiment I will be talking about is published in a paper, in a TSC paper. It was published in 2021. So if you want, I will make available the slides after the presentation, so that you have full information on anything that I will be talking about or discussing. So these are the contents of the talk. First, I will start with the overview of the study. Then I will explain the rationale for selecting the type of empirical study that we finally ran, which was a control experiment. Then I will go through the planning of the experiment. I will do a final assessment on the validity of the results. And I have included in the end some of the most relevant findings, although it is not the goal of this presentation to talk about findings or results of the empirical study itself. I thought it could be a good idea to have them in the slides, mainly because I will make them available to you later, just in case you want to see some interesting results without having to go to the paper itself, okay? But the idea is that I will not talk about the findings unless you have a specific question about that. My idea is to go through the rest of the items in the presentation. So I will start with the study overview. So we wanted to conduct an experiment exploring TDD, okay? I believe almost all of you, if not all of you, know what TDD is. It's a popular agile practice which emphasizes breaking the unit tests before writing the actual code, okay? So according to the authors, there are some benefits that come with TDD, which are improved design, it increases code coverage with respect to the test cases design, and it reduces the defects. However, if you take a look at the current literature about TDD, the empirical, mainly, literature about TDD, you will see that different studies report different results. They report contradictory results. We did a thorough examination of previous literature on TDD, and we came up with two possible explanations for this difference in results. One of the possible reasons for conflicting results in the results of the TDD studies were related to methodological aspects. So different studies had different design, they had different treatments, the sample size was different, and so forth, okay? But there were also another factors or another reasons for this difference in the results, and they could be due to other variables, other factors that were not specifically explored in the studies. So, for example, the tasks that the researchers were using in the studies. So we decided that this was an interesting idea to focus on those other unobserved factors. So the goal of our study, following the GQM approach, was to analyze development tasks and development approaches for the purpose of evaluation with respect to their impact on code quality from the point of view of the researchers in the context of software development. So with our study, we wanted to check whether, apart from TDD, the use of TDD or not TDD, if there were other factors, more precisely the type of task that was being coded, that could have an influence on the quality of the code generated when using these development approaches. So, in short, the idea is, are there characteristics of the tasks that could have an impact on the behavior of TDD? So, can we claim that TDD is an approach that behaves better overall, or should we apply TDD in certain circumstances depending on the characteristics of the problem we are trying to implement? So we had two different research questions. The first research question was, how does TDD affect quality compared to no TDD? And another one, how does the task selection affect quality during TDD and no TDD? These were our two main research questions. So the first step was, okay, we have these two research questions. We will go back to them again. Which is the study that best suits to answer them? Okay, so one of the important things that I would like you to take a look at is the nature of the research questions. We have, in both research questions, we have the word affect. Affect is a verb that, although maybe not explicitly, but implicitly, is suggesting causality. So we are, with our research questions, we are trying to answer a question that is causal in nature. So we want to observe the effect of something on another thing. In our case, we want to study the effect of the development approach and the task on the quality of the code generated with TDD or a different approach. Okay, so, and this is a very important thing, because one of the things that will help us to determine the type of empirical study we want to use is the nature of the research question. If our research question is causal in nature, we will have to go through some specific type of studies. If our research question is non-causal, then we will go towards another path, and we will have to use other type of studies. So, broadly speaking, we can categorize the types of empirical. I mean, there are many different classifications of empirical studies, but this is a possible one. Okay, so broadly, they can be categorized in either qualitative, quantitative, or mixed studies, which are a composition of both. Okay. So our research question is quantitative in nature. We are not asking about qualitative aspects. We want to know the impact of using TDD or an alternative approach and using a given task on code quality. So code quality is something that can be measured quantitatively. So therefore, we will go for a quantitative study. Okay, so there are different types of quantitative studies, but remember, I already gave you a hint. We want to answer a causal research question. So there are one of the type of studies that we can find in software engineering are descriptive studies. The goal with this type of studies is to describe the status of a variable. The researcher typically in these studies does not begin with a hypothesis, but will use the data to develop the hypothesis. So typical examples of descriptive studies in software engineering are case studies and surveys. There are also what are called analytical studies. These studies are not very much used in software engineering. In fact, I think there are like 4 papers at the most dealing with this type of studies because their adoption is very new. They attempt to establish cause-effect relationship, but the independent variable is not manipulated. So in other words, okay, and also there's no randomization. So this means that there is no intervention from the researcher as it happens in control experiments. So with analytical studies, we want to approach causality, but merely observing the setting with observational data. So for example, analytical studies could be used to study causal relationship in mining software repositories studies. An example of these are cohort studies and case control studies. As I just told you, there are just a very few studies, analytical studies run recently in the context of MSR. And finally, we have experimental studies. They establish cause-effect relationships. There's an independent variable or one or more independent variables, which can be manipulated by the researcher. And the researcher also can alter the setting so that he or she can control as many variables as he or she wants, okay? Experiments are the instantiation of this type of empirical study in software engineering. So the 2 first types are observational in the sense that the researcher does not actively manipulate or change something in the setting of the study. The researcher merely observes the data, okay? While experimental studies are interventional in the sense that the researcher manipulates the setting and manipulates the variables and is able to handle things. So they have more control, okay? So, and also both analytical and experimental studies allow to establish cause-effect relationships. But as I told you, analytical studies have been very recently adopted in software engineering. So by the time we run our experiment, analytical studies had not been yet adopted in software engineering. So you can forget about the analytical and just think that in software engineering, we have only descriptive and experimental. So at that time, our choice, since we wanted to study a cause-effect relationship, it was clear to us that we had to go for an experimental study. What is an experiment? Here we have a very brief definition. An experiment is an empirical procedure where key variables of our reality are manipulated in a controlled environment to investigate the impact of such variations. And as I told you, the main hallmark of experimentation is causality. So the main reason why we choose experiments is because they are able to derive cause-effect relationships. And our research questions are causal in nature. And this is something that I think it was important to clarify, because if we want to obtain causality, this can be done only through design, meaning that you cannot get causality just using statistical analysis techniques. It doesn't matter how powerful they are claimed to be. It doesn't matter how sophisticated they are. With statistical data analysis alone, it is impossible to obtain causality, to explore cause-effect relationships, okay? Data analysis support a causal design and will help us to study causality, but this is just because the design of the study allows causality, okay? And the only types of studies that can obtain causality are either experiments or also analytical ones, but remember that I told you that they did not exist yet in software engineering by the time we ran our study. And there are different types of experiments. So actually, there are 3 types of experiments. There are laboratory experiments, there are quasi-experiments, and there are field experiments. So our question, or we were wondering when we were planning or selecting the study type, we were wondering which one would be the most appropriate. So here you can see the main characteristics. So the 3 of them have intervention. Remember that it's what allows us to obtain causality. Randomization also helps to obtain causality, but we can see that in the case of the quasi-experiment, they don't have randomization. And then control also helps us to establish causality. And in the case of field experiments, control is, well, it's not really a no, but it's partial, okay? So we cannot control the setting or the environment as much as we would like to. And here you have the internal and external validity of each one. We have internal validity in all of them, but it's the strongest internal validity in comparison of the 3 of them. It's with the laboratory experiments. Quasi-experiments have a bit less internal validity, and and the field experiments are weaker than the other 2 for internal validity. On the other hand, with respect to external validity, with laboratory experiments, we get minimum external validity. With field experiments, we get maximum external validity. In this case, we wanted to not prioritize exactly, but we wanted, for us, external validity was important. Why? Because there were many previous studies on TDD that it was for us important to work with external validity. So typically, when there are few studies about a given topic, it makes sense to work on internal validity versus external validity. So laboratory experiments make more sense. But as there are multiple laboratory experiments that have already been run, it becomes more interesting or more relevant to work on the direction of external validity. And this is the reason why we decided to go for a field experiment. What is a field experiment in software engineering? It is an experiment with real developers working in a more or less real environment, okay? So now I will start with the planning of the experiment itself. Now that we have defined that we wanted an experiment because we wanted to study causal relationships, and we decided to maximize external validity, we decided to go for a field experiment. We are going to discuss, or I'm going to discuss, how the planning was done. Okay, and here are the steps that we need to follow when planning an experiment. They are inspired in Klaus Wolling's book, the Experimentation in Software Engineering book from Wolling and collaborators, but it's not exactly, I think I am not following exactly the same order, and probably maybe the names are not exactly the same ones, okay? So this is kind of adaptation that I have done from the process proposed in Wolling's et al. Book. So we will start with the variable selection. So from now on, I will go through all these steps and I will explain you about, I will try to justify or discuss the decisions that we made. So we are going to start with the variable selection. The variable selection step implies that you have to select your treatments or your factors or independent variables, and you have to decide what is your dependent variable. So we are going to start with our independent variables. According to our research questions, we have two independent variables. One of them is the development approach, and the other one is the development task. Let's start with the development approach, independent variable. It was clear to us, also because of the research question, that the exposed group, so one of the treatments, should be TDD. And if we go to the literature, it is more or less clear what TDD is and how it has to be applied. So, I mean, there's like a general consensus on what TDD is and how it should be applied. Why is this consensus relevant? Or what did I mention this consensus? Because it is going to help us to operationalize the treatment. So if there's consensus on how TDD has to be applied, it means that it will be easy, relatively easy for us to decide how the participants in the experiment will have to apply TDD. So, and the steps that will be followed are, first, the specifications will be broken down into smaller subtasks or slices, and then we will enter into a cycle, which is we will failing test has to be written. It will fail because there is no code associated to it. Then a minimal amount of code will be written to pass that test case. And once this has been obtained, the test case passes, then there's a step in which the code needs to be refactored. Okay, and then we go through the cycle. We started the cycle again, starting with the next slides. Okay, so this is TDD, and this is quite simple. However, for us, it was not that clear what no TDD means. We took a look at the literature again, and we found out that there was an inconsistent operationalization across the studies. Okay, so different studies operationalized no TDD in a different way. Actually, there's something that it's even worse than that, and is that the level of detail of the description varies in the different studies. So in some studies, the no TDD is very briefly defined, sometimes even with the name, test last, design code test, waterfall approach. And in other studies, in other papers, it was even worse because the definition was missing at all. So there was no definition of what no TDD means. And we believe that this is something very important. So as important it is the operationalization of the treated group or the exposed group as the operationalization of the control group. So we decided to focus or try to select a control group or a control that could be a fair comparison with TDD. Okay? So the first option was, okay, let's go to the waterfall. That was the first and logical option. We go and choose the waterfall because it's the classical approach and that would be a fair comparison with respect to TDD. However, there's a problem when, and this is something that has been reported also by previous studies, there's a problem when using the waterfall approach. If you remember in the waterfall approach, first there's coding, then there's testing. And the problem is that it could happen that participants in the experiment spend most of the time in doing the coding, and then they don't have almost time for doing the testing at the end. If this situation happens, then the consequence is that we are not doing a fair comparison because we are ending up comparing TDD versus something which is no testing. And we don't want to compare TDD versus no testing. We want to compare two scenarios in which there's testing, but in one of the scenarios, testing is done before coding, and in the other one, testing is done after coding. So in the end, we decided to compare. So the idea was to compare the test first feature of TDD versus an approach in which the feature was test last. Okay? So in the end, we decided to follow or use as control group the incremental test last approach. Okay? ITLD is how we have called it. What is the difference between this approach and TDD? They follow exactly the same set of steps. So it means that there is this breakdown into smaller subtasks or slices, and there's a cycle, but the cycle is different. In TDD, we started with writing test cases, then a test case, then coding, then refactoring. So here we write, the participants will have to first write the code, then do refactoring if necessary, and then test the code. Okay? So the idea is to compare test first versus test last. So the idea is to use two approaches that have exactly the same steps, but the only difference between them is the order of these activities. Okay? And that was the reason why we decided to use incremental test last instead of other approaches like waterfall that were presented in the literature. We have another independent variable, which is the task. So some tasks seem to be naturally easier to complete either using ITLD or TDD, okay? So we decided to choose these two ones, Mars Rover API and Bowling Scorekeeper. I will call them Mars Rover and BSK. And their main characteristics is that both of them are greenfield, both of them are algorithm oriented. A greenfield means that they are inspired in real tasks. Okay, so they are not toy tasks in that sense. They have a similar complexity, and we think or we believe that BSK seems to favor TDD, while Mars Rover seems to favor ITLD. Okay, we have this assumption or this idea or this hypothesis because of previous experiments that we ran about this topic. Okay, so Mars Rover is the development of a public interface for controlling the movement of a fictitious vehicle on a grid with obstacles, and BSK is computes or calculates the score of a bowling game. Okay, and here you have, just in case you want to go through the slides later after the lecture, if you want to take a look at some of the metrics of the different tasks of the two tasks, here you have a description of them. Okay, now let's move on to the dependent variable. We have the operationalization of both independent variables, the development approach, and the tasks. Now we are going to operationalize the response variable, which is code quality. If we take a look at ISO, then we will see that there are three different ways in which we can explore software product quality. So there's internal quality, which refers to the quality of the source code itself, and it measures internal attributes like complexity, etc. Then there is external quality that has to do with the completeness and accuracy of the software product. And then there's the quality in use, which is the extent to which the users can achieve goals. We knew that we didn't want to study internal quality. We don't want to know about the complexity or intrinsic characteristics of the code. And for us, the quality in use was something which could be interesting for users, but could not be interesting for developers. And we were interested in results which were interesting for developers, okay? So then we decided to go for external quality, okay? So we wanted to measure the accuracy and completeness of the software product. Okay, and then again, even if we want to focus on external quality, there are different ways in which we can measure external quality, okay? So our measure, this measure will be based on the number of successfully implemented steps. So which amount of the code or of the task has been coded, okay? So was coded and was successfully coded. So if BSK was like this big, how much of the complete task were able the developers, the participants in the experiment, to successfully implement or code. So previous studies have used different metrics for the external quality. For example, the percentage of passing test cases, or the percentage of passing assertions, or coverage measures, like, for example, the coverage of the test cases generated by the participants. For us, coverage measures were ruled out from the very beginning because they were not useful. Coverage measures can be useful to measure the quality of the testing, but they will not be useful for us for measuring the quality of the code itself, okay? And then we had two choices. Use a coarser granularity and measure test cases, or go for a finer granularity and measure assertions. And then in the end, we decided to go for this finer granularity because we thought it would be more appropriate, because it would give us an idea, a better idea of the exact functionality that was coded, okay? So with the finer granularity, we would be able to detect like small issues or small developments rather than going for test cases. Maybe passing test cases would have been more appropriate in a scenario in which you are not using TDD. Remember that with TDD, we have slices of the task that we need to implement. So we thought that because the specification itself has a finer granularity in the sense that it is decomposed in small slices, it would be a better idea to go for a finer granularity approach, okay? So we measure quality as the number of asserts that pass versus the number of the asserts, okay? So here you have the formula. And we will measure the quality. This quality will be measured. There were also different options for this. So should we use the test cases that the participants generated in the experiment? But we decided that we thought this would not be a good idea, because that would not be a consistent measure of the different participants. So different participants may have generated different number of test cases. Maybe some of them generated more, other less. So we decided that a more consistent approach and a better way of measuring the quality of the code generated by the participants was using our own test cases. So we generated a test suite as complete as we managed to, so that we could measure all different pieces of code. The code generated by the different participants could be measured with the same template, with the same set of test cases, okay? So this way, again, we would have a more accurate and fairer comparison and more accurate definition of the quality used, okay? Okay, so now we are moving to the selection of participants. This is quite simple. So there are different types of sampling. We can go for random sampling, or we can go for non-random sampling. In our case, we decided to go for a non-random sampling, even though, as you can see in the table, it is not as good as a random sampling, okay? As you can see, the generalizability with random sampling is higher. There is a lower risk of bias. However, it's harder to do. So we decided to go for a non-random. Specifically, we decided to go for convenience sampling, okay? So we choose professionals and that were working for a company. It was a Finnish company. I cannot disclose the name. I don't remember now, because we wrote several papers on TDD. And in some of the papers, we were not allowed to disclose the name of the company. I don't remember now exactly if this is one of the papers in which we couldn't disclose the name of the company. If it was possible, you will have the name of the company in the paper, okay? The important thing about the sampling is that the participants were chosen by the company itself. So we didn't choose the participants. The characteristics of this sample is that they have different experience in programming, and they also have varying experience in unit testing. but nobody had previous experience with TDD. Also, when the company choose the participants, they choose them so that they thought that they would be willing to accept TDD and later use it in the company. Okay, so something that I never wrote in the slides, but I wanted to mention is that this experiment was embedded in a training course. This means that this will affect some of our design decisions later. Okay, so remember that for the company, the company allowed us to run the experiment as long as it was training for the employees. Okay, so this was like the prerequisite or the requisite for running the experiment. So you're allowed to run this experiment if they get training on TDD. So you will see how this affects the design later, okay? So we finished with the participant selection, and now we were going to move to the design itself. Okay, so we have two independent variables, two factors. So the first approach or the first idea was, let's go for the simplest design. Okay, and the exercise I am presenting here, and in general, how I am presenting this lecture reflects how you should perform the steps when you are running an experiment, okay? So this means that when you're operationalizing the independent variable, you should precisely have in mind what you want to compare. Because if you don't operationalize properly the independent variable, then in the end, you will be comparing two things which are not the two things you wanted to compare. The same with the response variable. You have to be careful when operationalizing it, because if you don't do that properly, you will end up measuring something which is not what you wanted to measure, okay? You wanted to measure quality, but you are using a metric that does not help to use to explore quality. So for example, in the previous slides, imagine that we decided to go for measuring coverage of the test cases. This would have led us to an incorrect experiment, because that experiment would have a serious construct validity threat. You are measuring quality, the metric you are using for measuring quality is not correct. Or if we were using the waterfall instead of the ITLD, the experiment would have had a serious threat to the validity of its construct, because we would not be comparing fairly TDD against something that it's not TDD, okay? So when doing the exercise of the design, we always must begin with the simplest one, which is a between subjects. So we will see the type of exercise that we have to do when arriving to the final design. Okay, this is the simplest, between subjects. There are, okay, I never mentioned, but our sample size was 18 people, okay? So the company managed to get 18 people. So in this very basic between subjects design, we have 4 groups. Participants will be allocated randomly to each of these 4 groups. And there will be one session whether they run the ITLD or TDD with BSK or Mars rover, okay? So as I told you, this is the simplest design. However, there are a couple of issues with this design. So there are methodological drawbacks or issues or validity threats, whatever you want to call them. So here you have the design. In the right corner of the screen, you have the design so that you don't forget the design we are examining. So one of the problems is that we require a larger number of participants. So remember that we had 4 and 5 participants per group. This is not enough. This is very little. So we don't have enough participants. So, and if we go for this design, the power of the experiment would not be very good, okay? And another issue that we have is that this is something that it's not typically recognized, but when the sample size is very small, randomization tends to not to work properly, okay? So randomization is a very powerful technique against confounding, but if sample size is small, the smaller the sample size, the worse it tends to work, okay? So, and one of the things that it's going on in our experiment is that because the participants are people that are working for a company, the variation in the background of each participant is expected to be high. We expect high differences between the different participants. So randomization should work well. We are not 100% confident that it will work well, so perhaps we should go for a different design, okay? Additionally, there are drawbacks or validity threats related to the setting itself. So since the company chose the participants, we have no clue of how big the variability with respect to the different participants will be. And remember that I told you about this. The experiment is part of a training course. So this means that all participants should be fully trained on both ITLD and TDD. If we follow this between subjects design, it does not fit at all within in a training course, okay? We would be in trouble. Okay, so this is not the proper design, definitely. So let's go to the next one. Next one, within subjects design. Okay, here we have a higher sample size because we have two groups. There are two sessions. In the first session, participants apply ITLD, and then in the second session, participants apply TDD. So it's within subjects because all participants apply both development approaches and apply both tasks, okay? And the only thing is that the order in which they apply the tasks is different. However, they all apply the first day ITLD, the second day TDD. So this is a crossover design, but for tasks, okay? It's within subjects for development approaches, but it is crossover for tasks. Crossover because the tasks are crossed, okay? This is not the perfect design and it has issues. So one of the drawbacks, validity threats, issues, is that there could be information leaking. So since we are using the same two tasks on both sessions, it could be that participants talk to each other and they know about the task for the second day. And there's another issue. Okay, so this is like the main issue. However, we decided the mitigation action in this case was that we inform the participants, or we try to make them aware of the importance of confidentiality and data privacy, and also to make it understand that it would not be good for the experiment to have this information leaking, okay? So I think we managed to get it. They were not the students, so because with the students, this information leaking is more complicated. Most of the times because there's some kind of grading associated to the task, and that's what typically creates an issue or a problem with this. In this context, the participants were not graded at all. So this means that they were not so concerned by how well they were performing on the task, okay? Okay, so in the end, we decided to go for this design. So we could have opted for a more complex design, but the heuristic or the strategy should be start with the simplest one, go examine different designs with increasing complexity levels, and stop whenever you find one which is appropriate. None of them will be perfect. There will always be issues, but you have to stop when you have a reasonable design. And for us, this was a reasonable design. Our main concern was the information leaking, and we believe that we managed to avoid it. And okay, other control strategies that we use in this experimental design is that we kept constant the experimental environment. We didn't need, it was not necessary to use blocking in this experiment. We decided to measure participants' characteristics because, again, this is something that we're not able to control. And we use randomization when assigning the participants to the experimental groups. Okay, so this was the design itself. So next step we need to move on to is the operation. This was the procedure that we follow. Remember that this is a training course. So we designed it, the experiment or the procedure, we designed the experimental procedure, having in mind that it was a training course. So the first section was about ITLD. The second section was about TDD. And in both sessions, we did a training, first training, then the experimental session. And here you have a more detailed schedule. This is in the paper. So you can see that I have assigned colors to the different tasks, meaning that there are lectures, there were activities in the experiment related to lectures or theoretical concepts, which are the things that appear in green. So for example, we give a small lecture about unit testing, about the slicing this first day. There were exercises which appear in blue. So after explanations, there are always exercises. So after explaining unit testing, there are exercises about unit testing. After slicing, there are exercises about slicing. And sometimes they are individual. These are the solo exercises, but other times they are group exercises, okay? In gray, you have the experimental tasks, and you can see that they were planned at the end of the day. And those that appear kind of purple are other type of activities like coffee breaks, lunches, and so forth. This was the first day, and the second day follow a similar format. So there were lectures, this time about TDD and slicing in TDD. There were group exercises. There was a solo exercise with TDD. And there were also lunches, breaks, and so forth. And finally, at the end of the day, we had the experimental task. So remember, the schedule of both days has been driven by the fact that this should be a training course. Had this been a pure experiment, we had done the schedule in a completely different way, okay? And also, the reason why we decided to use 2 whole days was because the company specifically requested for that. They wanted us to use the minimum amount of days because since these are developers that are working in a company, it means that the more days they spend in the training course, the less time they work on their project. So 2 days was the minimum amount of time that we needed to run the experiment. Okay, now we have finished with the operation. We need to move on to the instrumentation. Which materials did we use for the experiment? Okay, so we needed materials related to the experiment itself, and we needed materials related to the training. Even though they appear at the end, I will start with the training ones. The training ones are simple ones. So we had to give lectures, so we needed slides. We had to prepare the slides for the training. And since the participants in the experiment would be asked to work or to do exercises, we need to prepare those exercises. So remember, the materials are always driven by the experimental procedure, okay? So these are the materials that we needed for the experimental procedure that we define, and that's it. We don't need to do more materials than strictly required. And of course, we cannot do less materials than strictly required. So in order to perform the experiment, the participants needed the specification for Mars rover and BSK. Also, we decided to provide them, the specification documents for Mars rover and BSK are like the minimum thing we need to run our experiment. But additionally, we decided to provide them, the participants, with more materials. So we also provide them with the code template for Mars rover and BSK that they could download from GitHub repositories. Why did we do that? Remember that we are measuring the response variable, the quality, on a predefined set of test cases that we developed. So that means that in order to plug our test cases smoothly with their code, we need a common interface, a standard interface for every participant. So the idea was that our test cases worked with the template, and the idea was that the participants would use the template to write their code. Okay, so the template in the end was the set of classes, which were empty. So we also decided to use Google surveys for demographics and also to collect subjects' opinions. And then we also needed a technological infrastructure. Okay, so we needed a room. So the company was in charge of finding a comfortable training room that was equipped with Wi-Fi, a project, and a whiteboard. Okay, so this is what we need for the experiment. Okay, we needed a project and a whiteboard for the training, and Wi-Fi connection was necessary for downloading the templates for GitHub and also for submitting the code once the participants finish with experiments. They used their own laptops, but we made sure that they had the minimum hardware requirements, which was 8 GB RAM, because we wanted them to work with a virtual box that we asked them to install before the experiment. Okay, in this virtual box, they had Windows, they have a web browser, Eclipse, and JUnit. Okay, and also the company gave us access to a shared drive where the participants could upload their code when they finish with the experiment. For the measurement procedure, we remember that we decided to use and create our acceptance test cases. And here you have the characteristics, okay? So, for example, Mars rover had 48 test cases, 132 assertions, and 11 subtasks, which are slices. And BSK was similar, okay? One important thing is that in order to be able to conduct the measurement procedure properly, participants must use the templates that we provided them. This is important, okay? This is a must. Okay, and then I will go to the analysis plan. I'm almost finishing because the analysis plan is quite short. Okay, I'm not an author of this book, but I always recommend my students this book. Even though it says that it's for SPSS, one of the great things of this book, okay, it has two great things. One thing is that there's an edition for R. So if you're using R, there's one discovering statistics using R. There's no version of the book for Python, as far as I know. And the other good thing about this book is that even though it says EEES SPSS, the organization of the chapters is always, for every chapter is devoted to a different statistical analysis approach or test, okay? And each chapter is divided into two different parts. The second part is the application of the statistical, how to run the statistical test with SPSS. But the first part is a generic part that can be read by anyone independently from the statistical tool that you are using. Another reason why I love this tool is because personally, whenever I have to run data analysis, I use IBM SPSS, okay? There's a long story about this, why I use IBM SPSS, but for me at least, is the best one. Is the one feel more comfortable with, okay? But you know, as always, there are personal stories behind this type of feelings and decisions. So at the end, in the last page of this book, that's another thing that I like from this. I mean, there are many things that I love from this book. But one of them is that the last page of the book, it's a kind of map in which it advises you the statistical test that you have to use depending on your design, okay? Which is lovely. I mean, it's something that I think it's really very much useful, okay? Another thing I would like to mention about this book is that, okay, I have been teaching a course on experimentation for almost 20 years now. And I use this book for the statistical analysis part of the course, okay? It's a master's course, yeah. Okay, so first we have to define our statistical hypothesis. So here we have the statistical hypothesis. They have to be derived from the design. So I mean, there's no other way in which we could write the statistical hypothesis for our experiment because they must match your design, okay? So by definition of what a null hypothesis is and what an alternative hypothesis is, and by definition of our design, which if you remember was 2 factors with 2 levels each, these are the statistical hypotheses, okay? And they cannot be others. For descriptive statistics, we decided to use box plots and summary statistics, okay? Summary statistics, reporting means, standard deviation, minimum, maximum range, etc. For inferential statistics, something important that it's in line with what I mentioned about the Andy Field book is that you cannot choose the statistical test that you prefer. Okay, this is a very common mistake when analyzing experiments. Actually, I know that you will not be able to attend because you are attending this school. But I have a tutorial at ICSE this year in which I am focusing on common pitfalls when analyzing the data from a control experiment, okay? So one of the pitfalls that I will go through in that tutorial is that you cannot choose the statistical analysis technique that you want. You must choose the ones, maybe there's more than one, there could be more than one, the ones that match your experimental design. So this means that if I have a design that it's 2 factors, 2 levels, there's no way in which I can analyze my data with 2 t-tests. No way, okay? Because of the design. If I have 2 factors, 2 levels each, I cannot run 2 different t-tests. I have to run a 2-way ANOVA or whatever, okay? So in our case, the decision of using linear mixed effects models was because we had a 2-factor 2 treatments within subjects crossover design, and because we had random effects, the participants, and fixed effects, the ones of the treatments, okay? And finally, with respect to the effect size, in those cases in which there is normality, we will use cohency. In those cases in which there is no normality, we will go for the coefficient R, which is described in Andy Field's book, okay? Okay, let's visit now very quickly which are the validity threats of our experiment. Conclusion validity. Statistical assumptions are not affected because we checked for normality and all that stuff. But the thing is that we have a very low small sample size, so perhaps we are suffering from this validity threat of lacking statistical power because the interaction between the 2 factors was not statistically significant. So this means that we were not able to detect the interaction effect. And this is because our sample size was not enough, okay? So here we have a threat. Another threat, Okay, these threads are taken from Wallin's book. No fatigue, no carryover, no practice, no knowledge of tasks, no attrition. Okay, we made sure that these things by design did not affect, or even though the design did not cover them, we made sure that they could not affect the results, okay? However, the selection of participants and the learning, there could be selection of participants effect and there could be learning effect, okay? We are not 100% sure. With respect to the construct validity, we don't have mono operation because we have two different tasks, but we have mono method because we have used just one metric for measuring quality. And one thing that may have happened is that we don't know the conformance to treatment. What is this? Do we know or can we guarantee that the participants use really TDD and ITLD? We are not sure. But this is a constant in control experiments, in general in empirical studies in software engineering. We do not know to what extent sometimes the participants are really following the treatments. We use this tool, Besouro. Besouro is used to measure, it helps you to measure conformance to TDD. So we were able to measure that the conformance to TDD was fine. So the participants were doing TDD. However, the problem with Besouro is that you cannot measure the conformance for ITLD because Besouro has been specifically designed for TDD. So we don't know to what extent the participants, when being asked to apply ITLD, really applied it or not. So this is a threat to the validity of our experiment. And then with respect to external validity, we were using professionals, but the results of the experiment are restricted to the characteristics of our sample. Junior to senior developers, which have experience with Java, which are beginner to novice in unit testing and JUnit, and that have no experience at all in TDD. So we cannot extrapolate the results of our experiment to other type of people, okay? People with other characteristics. So this is important because often it happens that we get reviews from experiments and the reviewers say, oh, but this is an experiment run with the students, it's useless. So here you can see that the solution, the silver bullet, is not using professionals, because still using professionals, the results of your experiments cannot be extrapolated to professionals with other characteristics, which are not the ones that the participants in your experiment had, okay? And then I will not talk about the findings. Remember that I mentioned that I included the findings just in case you wanted to go through the slides, but I would like to mention that we had a couple of deviations from the initial design. We had one dropout, and we found out that some participants did not use the provided template. So do you remember that this was a must for us? Okay, so some people did not use it. We don't know why, but we end up doing a small fix, and we slightly modified the code of these people to make it match. So the modification was minimum in the sense that we made the strictly necessary modifications so that the code would work with our test cases. Okay, no other modification was made. Okay, so remember that the rest are the results, so no need to discuss this in this lecture because it's not the goal of it. Okay, so I'm going to stop sharing.
Okay, I'm back. Lilian is back too.
Okay.
Let me just adjust here. Here, okay. So we have a few questions. Let me see. Oh, the first one is from Lilian. For each design decision, you showed how other researchers have approached similar experiments. When you are designing your own experiments, do you always make this kind of comparison to support your decisions?
Okay, it depends totally on the topic of the experiment. Sometimes we are running experiments and it is the first of its kind. So in that case, you cannot look at what others have done. But definitely, if you run an experiment and there are at least similar, if not exactly the same ones, but similar ones, it is a very good idea that you take a look at how the other experiments have been run before, to define the independent variables, to define the dependent variables. Also, maybe taking a look at the design could be useful, but the idea when doing this is not to copy them. Okay, this is something very important that we in software engineering must learn. This is something that in other fields, like physics, is done in a completely different way. They look at what others have done, but the goal is not copying things. The goal is to look with a critical view what others have done and then decide whether what they did was correct or not. There were previous experiments comparing TDD versus waterfall, but we believe that it made no sense, at least in our context, okay? So the idea is, so the short answer is yes, look at others, but try to use a critical view. Do not believe that because the paper was published in ICSE, because the paper was published in TSE, because the paper was published in EMSE, it's gonna be perfect. There's no perfect study. And experiments always have flaws. It's impossible to come up with a perfect experiment.
Okay, next question is by P. Cesar. Which code katas were used in the ITLD and TDD training sessions?
Yeah, okay, so I was not in charge of the training sessions. It was one of my colleagues, but I'm sorry that I have to redirect you to the paper for such information. But I mean, we use like the classical and typical approach to TDD. Okay, so we didn't do anything innovative at all.
Yes, the next question was by me, but you answered later. Yes, how do we know if someone is really following TDD?
In this specific case, we were lucky because there's Besouro. But we didn't know to what extent they were using ITLD.
Yes, I know Besouro because I was even one of the people, because the guy that at least the first version of Besouro was created by a guy called Bruno. Yes, I don't remember his last name, but he was a master's student at the University of Brasilia here in Brazil. Okay. And I was one of the subjects of his experiments.
Oh.
and he was not thinking about, he was only thinking about TDD, not ITLD. So maybe that's an opportunity for someone here that's trying to choose the subject for his master's to implement a tool that extends Besouro even to other languages, because I believe, for instance, a tool like Besouro nowadays would be more useful for something like Python, not Java.
Could be.
And the next question is by me. Did the research have to go through an ethics committee? And if it did, it was the companies, the university, or both?
Okay, so this experiment was run in 2018. So at that time, we didn't have to go through any ethics committee or anything like that, okay? Today, I can tell you what would have happened today, which probably is more interesting for you. As of today, we in our university, we only have to go through the ethics committee in case we are running experiment with our own students. Okay? If we don't run the experiment with our own students, our university does not require that we go through the ethics committee. Okay? But it's a good idea that you go through it, even though you don't run the experiment, because you never know whether you will need the approval of an ethics committee. Okay, but in this case, of course, the company approved. In fact, the way in which we organized the experiment itself, the experiment procedure was organized according to the needs of the company and the requirements of the company. Okay. And for example, when we released the replication package, data was anonymized. We explicitly asked for, we provide them with a consent, and we follow all the requirements from the company. Okay, there was not in the company a specific ethics committee or something like that, but the design was approved by them.
Great. We have had a talk in Portuguese, sorry, but for those that are here, it was about ethics in software engineering research by Professor Everton. And you mentioned that you are going to teach a tutorial at ICSE. I left the link here. And also there is someone mentioned the book Discovering Statistics Using R by D.F. Field and J. Miles. I'm not sure if it's from the same authors as the one you mentioned, but it's about statistics with R. And finally, we have Johan saying, awesome presentation, Professor Sira.
Thank you very much.
Thank you so much.
Okay, thank you. I hope you learned something about the procedure that we typically follow when we are planning experiments and conducting empirical studies.
I think we don't have any other questions. So, Lilian?
Okay. So, Sira, thank you very much. It is truly a privilege to hear about experiments directly from you.
Okay.
Adolfo, once again, thank you very much for your collaboration. Our next lecture will be with Professor Caroline Seaman from the University of Maryland, who will discuss qualitative studies with us. Thank you, everyone who joined us today, and also to those watching the recording. See you next time.
Okay, thank you to you. Bye.